Great. So our next speaker is Marcin, who is a tech lead at Ocado Technologies, and in practice also is a machine learning engineer. So what that means, loves to get his hands dirty with the code and to build end-to-end system, and he's going to share some of his experience on building a machine learning model, but put into production in a large company. So looking forward to your talk.
Excellent. Cool. Cheers. Welcome everyone. I know that everyone is starving, so I will try to speed up. First question, how many of you have the real experience in machine learning models in case of deploying this into production? Okay, cool. And the second question, how many of you are already using TensorFlow or write some models in TensorFlow? Okay, cool. Cheers. We are living in very interesting time. The number of research papers in case of the AI or machine learning is growing rapidly, and only in March this year 2,000 papers has been sent to the archives, one of the most popular websites with research papers. 2,000 a month, it means that it's over 60 a day, so it's very hard to keep yourself updated. It's very hard to even go for holiday. And good news for you, I will not show you a research paper. I will focus more on the how to deploy and use very simple methods, but how to deploy them into the real system, to real production and real business as well. Who am I? I am a data scientist and machine learning engineer at Ocado. I have more than 6 years of experience in data processing and machine learning in large organization. Most of the experience got with the Apache Spark technology, TensorFlow, strong Python enthusiast. If you want to drop me an email, feel free, or connect me through LinkedIn. During my career, I was working on many different machine learning projects. Some of them is customer segmentation, when you want to split your customer base for marketing reason, and demand forecasting as well, where you want to predict how many orders you will have next week or next month. I'm working for Ocado. How many of you are familiar with Ocado or heard about Ocado? Right. It's for all of you who never heard about Ocado, we are the largest online grocery retailer. And the problem which we are solving is just saving people like you time. So you don't need to go to supermarket, we will deliver the food to your doorstep. Because we are fully online, we keep whole stock in the highly automated warehouses, and we are writing the whole software to manage these warehouses in-house, so we have more than 1,000 developers and engineers and data scientists to manage this stuff. As I said, we are fully online, we don't have the physical shops at all, and that raises a lot of problems as well, because our customers cannot ask saleswomen for help with the products or something like that. So our business has only 2 points of real contact with customers: the drivers when they are delivering the food, and the second one when customer will decide to call us or write us an email through our contact center. And today I would like to share the experience of deploying the natural language processing project into the contact center. So how the typical contact center work? As you can imagine, customers can write us an email about almost anything, and when I'm saying anything, it really means anything. Some of them asking for some refunds, some because the product was damaged. Some of them wants to add another product to our website, but some of them also raise an issue about some payments or web shop issues. So plenty of issues, and in typical contact center, most of the typical contact center works in a FIFO manner, so first in, first out, or first in, first served. And that's not an efficient way of working, because it might happen that you will write an email about your blocked credit card or something like that, and that email will land at the end of the queue just after some spam emails or low important stuff. So when contact center manager came to us to ask for some help, to us data scientists, first what we did, we just turned off our computers, we went there, And for whole one day, I became the proper contact center advisors with my own headphones, and that one day learned me more about the data science work than the probably 3 or 4 years of working in the industry, because I've learned that to deploy machine learning properly, you need to really understand the environment when this machine learning will work. You need to really understand how the serving and production looks like. And when we went there, we saw that the reality looks more like this. So plenty of emails coming every hours, and we don't know the content of emails until we read them. But when you read this email, sometimes it's already wasted time because it's a spam or something not important, or there is no immediate action needed. The business goal, because to deploy machine learning into business, you need to have a very clear and well-specified business goal. So the business goal for this project was pretty simple. At the end, we would like to see a chart like this. On the x-axis, there is the urgency of the email. On the y-axis, there is a time spent in a queue for that email. And we would like to see that the very urgent emails, they are not sitting in a queue almost at all. And this low important can be handled in hours. What we did, to give you an example of the real email from the customer, the user told us that she's loving our website, she has children, and that's why she's using us at all. We built a classifier which assigned the appropriate tags to that email. So for this email, our classifier would return 2 tags. That the mail is the feedback message, and based on the sentiment analysis, we can say easily that customer is very happy here. So based on these 2 tags, later we can determine what is the urgency and what is the real priority of that email. And as you see here, it's not very, there is no immediate action needed. We can, of course, we should respond to this kind of emails, but it's not that something will happen if we will respond in 3 or 4 hours. When we started that project, we thought that the best way will be to just try to predict the priority of the email. And probably that would be the easiest one, but we learned that when you want to build the machine learning for the real business, you need to be very, very flexible, and the definition of urgency in business changed every day. So when there is a problem with warehouse, they have other definition of urgency. Right now, the damaged item should be the top priority one to handle, because there is plenty of them. So that's why we decided that our machine learning should just only return the tags, and later other systems should determine what is the real priority for today, let's say. As you see, there is plenty of different categories. In case of the just machine learning, it's a pretty simple multi-label classification problems, very common in NLP. So as every data scientist, we need to choose the right metrics to train our models. We went for the F1 score to have the nice to have a nice trade-off between precision and recall. And because of fact that we have more than one tag, so it's not binary, we average through all classes. And the whole matrix is sometimes called in a literature the F1 macro. There is no proper data science presentation without complaining about cleaning data, so let's do that. In case of the emails, as you can also imagine, there is plenty of PII information there. People share their postcode, people share their telephone numbers. Sometimes in the footer you shared it because your email client did it. So we used a lot of regular expression, a lot of different natural language processing techniques to get rid of this PII, because I don't really care if that mail comes from John or Jose. I only care about what is the content of the email in case of the anonymized content. Of course, to build the classifier, you also need to think about how will you structure your dictionary, and also somehow get the labels, and that's a pretty hard topic always. So the best labels always comes from people. So we need to get that from all systems. And when you have the already clean data set, everything is prepared, it's very, very tempting to just go to one of these websites, research papers, let's find the state-of-the-art model right now and rock and roll. But that's a way why we shouldn't work in a business. We always should think about the assumption. We always think about what we really want to check. And from my experience, 100% of data scientists overcomplicate their models, and that's what we also did. But to start, to ensure that the whole systems at all make sense, we start with the logistic regression on the top of the back of words to see how it will behaves, and that few lines of code behaves significantly better than just random, and that allows us to really validate that the whole data pipeline works, that everything's really can do the work. And the feedback from the contact center was that, guys, system is amazing, but the accuracy is really poor. And that kind of feedback you would like to hear as a data scientist or as a machine learning engineer, because that's where the fun really starts. So later we decided that, okay, let's take some more sophisticated models. We go for the convolutional neural networks on the top of the embedding layers. We check this and compare it to the recurrent neural networks, the pretty standard stack in case of the neural networks. We wrote code in the TensorFlow. So for these few people who are already using TensorFlow, a few tips. Probably you never heard about the flags. It's very simple, thin wrapper over the ArcParks Python library to expose your parameters, model parameters as a command line parameters. And thanks to this simple module, later we can get the very nice reproducibility. I will show you that later. TensorFlow also revolutionized a little bit how we are storing the graph, how we are storing the neural network. So if you never use the saved model and you still don't know how to transfer model, how to restore them, saving checkpoints, that's definitely a thing to do. And if you are writing a lot of code in TensorFlow, definitely you will need the last dot, I mean the TFDB, the proper TensorFlow debugger, and use a lot of TF-assert to make a proper assertion about your tensor shape, etc., etc. So, plenty of tips. In case of the TensorFlow, it's not very easy framework to start code, but there are some models already written there, and one of the model common in the NLP space is the word-to-vec. So in word-to-vec, what we want to do is to change the words into vectors in such a way that the words with similar meaning will be very close to each other in the vector space. Very simple thing. If you want to evaluate the word-to-vec, you can use some kind of the equation, like here in the London, Paris, and the capital of the country, or other things. Or you can also check the final precision and recall of your algorithm. What we did, because if you have plenty of data, you can, this very simple algorithm like word-to-vec can do a real magic. And I have a very quick quiz for you. I showed 5 other words very close to each other in the vector space. And that's a quiz for you. What is the hidden under the question mark? So what is the word very close to this which I showed you already. On the left, let's start with the left. Beer. Excellent. Well done. And second? Close. Nope. Good shot. Nope. So overall, it's the word competition. Competition. And that's like all management books says that you should listen customer, and this is the final proof, because they will not only tell you what they want to drink, but also where they will exactly go when you screwed up. So that's a very nice if you have a lot of data. The training neural networks and before deploying neural networks, you need to be very, very careful in case of the hyperparameters. And finding that best architecture is sometimes very important to success of the model. The models are very, very fragile and very, very sensitive to the starting parameters, to any change in the starting parameters, not only in case of the learning rate or the filter size, but also the number of units and the way how you decay or number of epoch. In case of the hyperparameter tuning, you have plenty of choice what you can do with hyperparameter tuning. The very straightforward grid search, you just exhaustively go through the whole space of the parameters and check every set. Pretty simple, but not very efficient. There is another approach, random search, which works really, really well, surprisingly well, where you just sample that space and that's all. There are also much more sophisticated approaches with Bayesian optimization or tree of Parson estimators. Like always, you don't need to write any code. It's already written for you and already on the GitHub, so there are very good Python libraries to do the hyperparameter tuning. How the whole solution looks like. So when the new email comes to the queue, the contact center application sends us just the content of that email. The machine learning just returns the tags. And the good thing is that contact center also sends some events to BigQuery, where later we can analyze it through simple SQLs, how the whole systems behaves. Most of this software is deployed into Google Cloud. When you have the people in the process, and here we are deploying the machine learning into the real contact center, so it will change how the people behaves. And you need to be very, very careful when you are deploying any system where there is a feedback loop inside or where is the real person inside. One of the good example is detecting the sarcasm. So we got the email from customers after first damaged his birthday cake, and one of the British people, and British people use a lot of sarcasm. So he sent us the message, "Thank you, Ocado, I will have a great birthday." Because we damaged his birthday cake. And of course, machine learning treat this as a customer is happy at the end of the queue. and to handle this kind of situation, the good approach is to always have some real people in the process. So rather than thinking about how the machine learning will look like versus humans, we should think more about how the human plus machine learning can work. So how we can augment the people by the machine learning and by smart tools. Okay, we did it. We deployed the machine learning into production, and most of the data scientists, most of the data engineers, everyone just go and celebrate. And that's not how we should do. I mean, in case of the business, when you deploy the project, it's just only the beginning, because everything before it was just only the investment from their side. So right now they want to see the value, they want to see how much money we really made on that. And the funny thing is that most of the projects, machine learning projects, not fails before deployments, most of them fails after deployments. Because if you can notice that it will fail, you will not deploy this. So it's pretty simple. Why most of the project really fails later? First, because of the lack of the monitoring. So what we did to have any monitoring there, we encourage the 10% of the advisor to manually really check and confirm our tags. So our tags are confirmed by the real people, and we can really show how the accuracy looks like. And this is the real screenshot from our convolutional neural network model. The second reason why most of the machine learning projects fails is that data scientists forget that they are writing a software. And when you finish the experiment phase and model works pretty well on training data set, you are so happy and so amazed that you want to just go into production with that. Many data scientists forget that the code should be versioned at all. Many data scientists forget that they also should write some tests to code. So plenty of reason, and there is a software engineering practices have been developed through a lot of years, so you can very easily learn this stuff. Go to GitHub, find the great project, and see how they are set up in case of the continuous integration, etc. In our case, we not only storing, because in big companies, this kind of software engineering practices are already done by the years, but we also focus on the reproducibility. John Ioannidis, who is the professor of medicine at Stanford, claims that most of the research papers findings are false. He and his colleagues analyze many of different papers, and they just try to obtain the same results as author of the paper claims. And only in small percent of papers they were really able to get exactly the same results. And that only shows that the reproducibility is very important. And for us, this reproducibility is not only the code, what has been generated, but also in which environment, and that's why the Docker is there, and also the data. So that's why the Google storage is there. So how we are achieving the reproducibility of our models? For every models in production or every model in development phase, we have this kind of very small JSON files where we keeping the information about from what code that model has been trained, in which environment, so in which exact Docker file, Docker image, from what data, and also from what parameters. And these parameters are pumped by this G-Flags module from TensorFlow, so we are getting them for free. Just to reap the benefits of the project, after deployments, the urgent emails are responded 4 times faster. We've surprisingly also saved some money, because it turns out that 7% of the emails shouldn't be at all read it. It was the spam emails or thank you messages. So we saved 7% of the overall performance. And the whole project has been shortlisted in European Contact Center Award in category Innovation in Technology. What next? What we can do with this very simple solution? We can track the sentiment over time, and retail is very, very competitive space, so we want to also see how our customers behave during the Christmas, when is a busy time, and see how the sentiment looks like over a year. We can also have the very simple monitoring almost for free, so if we see the spike in the damaged item, we can notify the spike in case of the rate of the emails which comes with the particular tag. We notify automatically the warehouse team to do something with these damaged items. So right now we are researching how our contact center advisors could get the templates to respond by templates. So get the templates already prepared for them, and they should only fill in some basic information. So why deploying machine learning in business is so hard? Because we as a data scientists, researchers, machine learning engineers, we are only seeing this, this tip of the iceberg. But behind the scene, there is plenty of people, plenty of processes. The machine learning will affect the KPIs, SLAs, and you also need to think about even anonymization, GDPR, etc. So there is a lot of things which can go wrong, and it will go wrong. And the best thing which I can recommend is just switch off your computer, go for a beer with engineers, with business, understand how the environment where your model will work, how it really looks like, because the best products comes from the people interaction. So at the end, I wish you all just only a successful deployment. Cheers.
Any questions for Marcin? Could you sway to the mic, right? So.
Hi, I just have a question on the sarcasm that you were mentioning, so the happy birthday things.
Yeah.
So you briefly mentioning that a human-machine interaction will be working better, if I understand, to detect that.
Yes.
Or anyway, how do you cope with that problem?
So it's not easy to cope with that automatically, and as I said, 10% of the advisor still manually read the emails and check them. So we can spot this. That's how we at all spot this kind of cases. For 90% of the emails, we don't have the automatic solution yet. There is some research papers how to detect the sarcasm, and in our case, we can detect this based on the some fails in case of the human, customer interaction. So we could spot that we got this damaged item in the first email, and later, rather than respond, rather than think that customer is happy, we should treat these customers as a, because we got from the another system that it's a damaged item. So we should somehow, mix this data from different data sources and inference that maybe it's not a customer is not happy more, and it's just sarcasm. But detecting this is a very hard problem, and there is plenty of good papers about it.